also differentiating exponential and logarithmic functions. Okay, so first a review. So let's do a review. So first on exponentials, or just exponents. Okay, so as you know, a power m is equal to a times a times a, right, times a. Of course, multiply a by itself m times. Okay, this everybody knows. Then there are some properties. Okay, so the properties is that a power n multiplied by a power n is equal to, what is it?
A to the power to m plus n.
So a, you just add the exponents, a to the power of m plus n. When we divide a power m divided by a power n, of course, we subtract the exponents. Okay, then a power m power n is equal to a power m times n. Then a power 0 is what?
1.
Okay, that's 1. Of course, only if a is not 0, right? If a is 0, then we have 0 power 0, and that's, you will see soon, it's an undetermined form, and we have to do some, I have to teach you this as well, okay? And then a to the power of negative n, what is that?
1 over a.
1 over what?
A to the power of n.
A to the power of n, again, given that a is not 0, okay? Or else we're dividing by 0, and it doesn't make sense. And the last one, if you have a power 1 over n, what is that?
Square root of a.
So the nth root, not the square root, but the nth root of it. Okay, the nth root. Okay, so these are the basic exponents rules. Do you need examples, exercise on this, or you're fine with this?
We're fine.
You're fine, okay, I think you're fine with this, okay? Anyways, I could post some practice. I will post some practice if I didn't do so already. I don't think I did, so I'll post some practice on this. Okay, now, logarithms. Okay, so how does it work? The log in base b of x equals y. This means that b power y equals x. This is the definition of the logarithm. Okay, so when I say, listen carefully, when I say the log in base b of x, what I'm looking for is what should I put b to the exponent to get x. So I'm looking for the exponent. The answer here is the exponent to b. Okay, b power what? B power what will give me x. Okay, so maybe an example. This one deserves an example. The log in base 2 of 8 equals what? What's it equal to?
3.
3.
3, exactly. Because 2 power what will gives me 8? Well, it's 3. Okay, since, I write it, 2 power 3 is equal to 8. Okay, that's how it works. And now there are the properties. Okay, there's 4 of them. So log in base b of x plus log in base b of y equals what?
Log of b x times y.
So not log of b, log in base b. Okay, so it's important to say it correctly. Log in base b of xy. Okay. Second rule, same thing for subtraction. So log in base b of x minus log in base b of y will be log in base b of
X minus divided.
x over y. Okay, that's the second rule. Third rule, log in base b of x to the power of a. What can you do with the a?
Bring it in front.
Begin in front, so it's a times log in base b of x. And the last one, log in base b of x divided by log in base b of y. You know this one? No?
Log of y of log of base y of x.
Yeah, so it's log in base y of x. Okay, so this is how, these are the 4 properties of logs. Okay, 1, 2, 3, 4. And these are all the properties of the exponential, the exponents. 3, 4, 5, 6 of them. Okay, of course, there's more, but more you could probably deduct them from here. Okay, okay. Would you like examples of these things at the bottom? Anybody?
Yes.
Yeah, okay, so here's an example of each. Okay, I'll try to fit it here. So for example, so log in base, let's say 6 of 4 plus log in base 6 of 9 equals what? Well, it's equal to log in base 6 of 4 times 9, which is 36. And that is equal to 6, right?
Equal to 2, no?
It's equal to 2, okay, not 6, okay? So you could be tempted to do 6 here, because 6 times 6 is 36, but it's not times, it's power. So 6 power what gives me 36, so this has to be 2, okay? Example, log in base 2 of, let's see, (40) minus log in base 2 of 5. Okay, so that will be log in base 2 of what?
Of 8.
So 40 over 5 is 8. And that's, of course, 3. Okay? Example here. Log in base 5 of 25 power 15. Okay, so this is equal to 15 times log in base 5 of 25. and that's 2. So 15 times 2 is 30. Okay, and last example. So log in base 7 of 32 over log in base 7 of 2 is equal to
Log of,
what?
log of base 2 to the 32, 32.
Of 32. Very good. Log of 32 in base 2, and that is equal to 5, because 2 power 5 is 32. It's okay?
Yes.
Okay, that's it. There's much more to say on log, so we could prove all these. We could prove these 4 formulas. I don't know if we should. I mean, I proved everything with almost everything in trig. But I think we should advance because we're already into, we're deep into derivatives, so might as well continue with the derivatives now, okay? If you want, after I could prove them to you if you want. Okay? It's not long, okay? But I just want to continue with derivatives for a bit, okay? Unless you want more practice on this, but anyways, I'm going to post some sheets. Okay, questions? Did anybody never do logs? I just want to know. That's important. So everybody did logs before. Okay, I don't hear anyone, so I'm guessing yes. Okay. Okay, so if you didn't do logs, never, just send me a chat privately, and I'll know that you haven't done it. Okay. Okay. So let's go. First thing. Okay. So what's Euler's constant? You know this one? It's
2.71.
exactly. He is 2.718. I don't know, 28. Let's see. Let's see right here. So 2.71828. 1828, and it goes on forever. Okay, it's an irrational number. It's just like pi and square root of 2. It's an irrational number, and it's very has very good like it's very practical. You'll see in math. It comes up a lot. Okay, how do we find Euler's constant? Okay, so one way to do it. There's another way. Okay, but one way is to do the limit as x approaches infinity of 1 plus 1 over x to the power of x. Okay, this is the exact value of Euler's constant. Let's try. Okay, let's try putting a very big value for x here. Okay, so look, if you have infinity, if you put infinity here, you'll get 1 plus 0, right? Because 1 over infinity is 0. So you get 1 power infinity. Okay, so 1 power infinity is an undetermined form as well. Okay, as we will see very soon. 1 power infinity, and that's an undetermined form. Okay, and the proof for that is that if you start putting big numbers for x, for example, let's say x is 1,000,000, 100,000,000, 1 billion. Okay, so x is 1 billion. Okay, so 1 over that plus 1. So I get 1.00 power 1 billion. There you go. You see? I get 2.718281827, right? I'm off by 1 decimal at the end because I didn't go high enough. Okay, I just did 1 billion, but of course, 1 billion is very, 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 very small compared to infinity. Okay? Is this clear so far? Okay, so let's write down the derivatives and then we're going to prove them. Okay, so just one thing, you know ln. I didn't tell you what ln is. Okay, so ln of x is what?
E
So it's log the
of
base
E.
of x. Okay, ln, when you see ln of x, it means a log, just like we did before in the last sheet. But the base, instead of being a or b or whatever, it's e. It's this number. Okay, and when you have a log of x and there's nothing below, what does it mean? What's the base?
10.
10. Okay, so just to clarify things. Okay. So let's go with the derivatives. Okay, so now every time I add a new derivative, you see I have much more options to do chain rules and quotient rules and everything. Okay, so far we did derivatives with regular algebra and also with now trig. So now there's going to be logs and exponentials involved. Okay, so the derivatives are follow. First of all, if f of x is equal to e of x, so let's start with ln x. So if f of x is equal to ln of x, then the derivative will be, does anybody know this one?
1 over x.
Yeah, it's 1 over x. Okay, the derivative of ln x is 1 over x. Second, let's say the base is not e. Let's say the base log in base, let's say e of x. What's f prime? Okay, let me just use a. I want to use log in the base. Okay, so this will be same thing, 1 over x, but I will divide on the bottom by ln of a as well. Okay, so all these you have to know by heart. Okay, but anyway.
Excuse me, sir.
Yeah.
What is that you wrote? Like 1 divided by
Here? Where?
husband?
Here or here?
Okay. No, it's clear now. Thank you.
Okay.
Oh, sir,
Yeah.
why isn't it 1 over x log of a?
Why is it
Why isn't it log of a? Why is it ln?
ln? Why is
Yeah.
it
Why isn't it log?
log like in base 10, like here, log?
Yeah.
Okay, I'll show you. We're gonna have to prove it. We'll prove it.
Okay.
Okay. And then 2 more. So if f of x is e of x, and then if f of x is any number power x. Okay, so these are exponential functions. Okay, where the x is in the exponents. The derivative of e power x,
Isn't it e of x?
it's e power x. It's not e of x. E of x is, no, it's e power x. And a power x will be
A little bit sympathetic.
same thing. A power x times ln of x, multiplied by the ln of the base. Okay?
Yeah, so every night Paul asks her, "Are you happy?" And every night Angel says, "Yes, she is."
Okay, questions?
So E of X is the same thing, right?
E of X, the derivative stays the same. Okay, that's what's so interesting about the E constant. Okay, because everything else, any other number, if you want to derive a power x, you'll have a power x times the ln of a. But e power x, you'll have e power x times, well, ln of e, but ln of e is 1, if you know. Okay. Okay, so these are the 4 derivatives, and now we're going to try to prove them. Okay, so the hardest one to prove is the first one. That's why I put it on first. Okay. So any questions so far? Okay, so let's start with the proofs. So proof that if f of x is equal to ln x, then f prime of x is equal to 1 over x. Okay, so that's what I'm trying to show. Any questions until here before I start proving it? Okay, so let's go. So f of x is equal to, I'm going to go back to my definition of the derivative, okay, because it's a new function for us. So definition, f of x is ln of x, f prime of x, f of x plus h is what? What is it?
Ln of x plus h.
So ln of x plus h, good. Okay, so f prime of x, my definition tells me that it's equal to the limit as h approaches 0, f of x plus h minus f of x. So ln of x plus h minus ln of x over h. So far, so good? Okay, no questions? Okay, let's work on this a bit. Equals limit h approaches 0. So I'm minusing 2 logs, right? We know that if we minus 2 logs, then we could just write 1 log and divide them, right? So it's x plus h over x. It's one of the properties of the logs. Is this okay? And then over h. Who's got questions so far? Okay. Let me just write it a bit nicer. So I'm going to put 1 over h in front times, okay, so divided by h or times 1 over h is the same thing. And then here I will have the ln of, well, x plus h over x is like 1 plus h over x.
Can you explain the 1 plus h over x?
Yep, it's x over x plus h over x. I'm separating the fractions.
Oh, okay.
Okay, x over x plus h over x. And I have 1 over h in front. Is this good?
Yep.
Okay, anybody? I'm going too fast for anybody. You stop me.
I don't understand why you have the h 2 times in it. Like,
Which
Yeah.
h?
well, you have the 1 over h and the h over x.
No, the h over x comes from here, this h. And the
And
1
what
over
is-
h is,
Oh, okay, sorry. I didn't realize that.
okay, equals limit as h approaches 0, ln 1 plus h over x. And of course, if I have a multiple in front, I could put it on top of here. 1 over h, same thing, right? Because I'm allowed to drop it in front, right? The exponent. This is the third rule that we showed a few minutes ago. Okay, who's got questions until here? Okay, no questions. So now comes the tricky part. Okay, so I'm going to do now, I'm going to change variables. Okay, so I'm going to let, okay, I'm going to let x over h, so x over h, okay, that's h over x, but x over h, I'm going to call this, let's say n. Okay, so this means that 1 over h is n over x. Do you understand this?
No.
No? So x over h, I want to call x over h, I want to call it. Okay, and you're going to see why I'm doing this. Okay, I'm calling x over h, I'm calling it n. So this is me, I'm bringing this to the table now. Now, from here to here, if you accept this, that I brought this, then this should be easy for you. I'm just sending the x on the bottom. I'm just, right, this is like over 1. And so if you could send the x on the bottom here, I get this.
Okay, I get it.
Okay, so look, what does this bring to me? Is that as h approaches 0 from the right side, then n is approaching, well, x over 0 plus, this is approaching positive infinity. Okay, do you have any questions?
Yeah, can you explain the h approaching 0 again?
Yeah, because h, you see h here, I took it from here, and h is approaching 0. Okay, so h is approaching 0. So x over h is approaching infinity. Right, a number divided by 0 is infinity. Remember this? We did this. It's a vertical asymptote.
Yeah.
But
Okay, no,
I'm expecting a question, which I'm not getting. That's why I'm taking my time. Okay, so a number over 0, I'm telling you, it's if h is, if the denominator is positive, then the x over positive will give me positive infinity. But the question you have to ask me is, how do I know that x is positive? Maybe x is negative, and this would be minus over plus with minus infinity. Do you understand my question?
yeah.
So anybody have an answer for this? Okay, so the thing is that f of x is ln of x. And ln of x, the x cannot be negative because ln of the negative doesn't exist. Okay, so from here I see that x is for sure positive, or else it doesn't make sense. Okay, ln of x, so it's clear that x, from here I know that x is greater, strictly greater than 0, not even 0. It can't be 0 because ln of 0 doesn't exist as well. Okay, so that's why x is a positive number, h is approaching 0 from the plus, plus over plus is plus, and a number over 0 is infinity. So I get n approaches plus infinity. Any
Why
questions?
doesn't the negative exist? If it's, for example, if it's a pair number, if it's an even.
If what's even number?
I kind of get like why it wouldn't exist, but at the same time, like, for example, ln minus 2, base minus 2, and then on top you have.
No, we're not gonna go with negative bases. Everything positive here. Okay, ln function, the base, well, ln, first of all, the base is e, so that's a positive number. So that's, you're talking about something else, talking about log. Okay, and that's another problem. But let's say log in base e, the base is positive, and x for sure has to be positive, or else it's not defined. It's like doing the square root of -2. Now, you can do the square root of -2. We go into imaginary numbers, and that's, it's not in this course. Okay?
Hi. Is it just
Yeah.
me and you?
Hello?
Because I'm waiting for other people. Usually we're like 4.
Okay, gonna mute. Okay. So if you understand, this is the tricky part. If you understand this, the rest is gonna go fine. But would you like me to repeat this part here?
Yeah, please.
Okay, so again, okay. So I got until here, you're fine. Who's not fine until here?
Yeah, it's good.
Anybody else? Anybody not fine? I don't mind repeating. Okay, so I'm assuming that this is fine. Now, after that, what I did a substitution. I said, 1 second, let's call x over h. So here I have h over x, but let's say x over h, I'm gonna call this n. Okay, I decide to call it n, and I wanna see how does n behave when h is approaching 0. We did something similar when we did the proof for the chain rule. Remember, we did k, when h approaches 0, k approaches 0. So the same thing here. If h approaches 0, then n will go to infinity. Because h is very, very small, means that n will be very, very big. Is this okay?
Yeah.
Would it work if we made h over x equal to n?
Then n will go to 0 as well. Yeah, it will work also. Okay, but you'll see why I'm writing it this way, because I want to slowly lead you to something that we could recognize.
Okay.
Okay, so let's go now. I'm just gonna put a box around here to show that it's an extra, like something on the side. Side note. Okay, and so now I'm gonna come back here. And I'm gonna rewrite everything with my new variable, which is n. So now, limit of ln of, so 1 plus, so h over x is what? If x over h is n, h over x is what?
1 over n.
1 over n. Good. And 1 over h now is n over x. Do you understand this? Anybody? Questions? Every step you have to stop me, yeah?
Sure. What happened to the h approaches 0 under
We're getting there. Good. Very good. Good question. I'm getting there. Okay. So I just want to make sure that the algebra part is good here, right? 1 over h. So 1 over h is n over x. Good. And x over h is n. So h over x is flipped 1 over n. Okay. Now, your question, which is very good, what happens if the h approaches 0? Well, you know what? There's no more h here. You see an h? I don't see an h. The only thing that's going to infinity or 0 in this case is now n. Okay, so was h approaches 0, now it changed to n approaches infinity. Is this okay?
Isn't it plus infinity?
What?
Why don't you write plus infinity?
Yeah, same thing. Yeah, same thing.
Okay.
Same thing. Okay, so equals to limit n approaches infinity, And so I'm going to go like this. Ln of 1 plus 1 over n to the power of n, and then all this here to the power of 1 over x. Same thing. Because 1 over x times n is n over x. So I did not change anything from here to here. I just wrote it this way because I want you to recognize something. Are we okay with this?
Can you explain that?
This step here?
Yeah, the exponent thingy.
This here? Okay.
Right, yeah.
So you just, if you multiply the exponents here, right? When you have something, power something, well, you could multiply the exponents. So if you multiply n by 1 over x, you get n over x.
Okay.
Okay? Okay, and now why did I do this? Because now I could bring, I have ln of something, power something, the power I could bring in front. Okay, so equals to, well, okay, limit as n approaches infinity of 1 over x times ln of 1 plus 1 over n power n. You guys okay? We're almost done. I'm going to write here because I need the last line. Okay, let me know if you have questions before I write. Okay, so now I could extract the 1 over x outside because it does not depend on n, so I don't need it in the limit. Times, and now the limit I can incorporate wherever I want. So I will incorporate it inside the ln. So it's ln of limit n approaches infinity of 1 plus 1 over n power n. And do you remember what that is, this limit?
E?
Yep, that's E. That's what's the definition of E. And so we have 1 over x times ln of E, and ln of E is 1, right? E power what will give me E? Well, 1. And so my answer is 1 over x. I just showed that the derivative is exactly 1 over x. Okay, that's out of the 4 proofs, that's definitely the hardest.
Sorry, sir.
Yep.
I don't understand the last step.
The last step?
Yes.
Okay. This step, this one here or here?
The one at the beginning.
This one here?
Yeah.
Okay, so this you're okay?
Oh, yeah.
Okay, so the only thing I did from here to here is I took the limit, oops, I took the limit and I put it inside the 1 because there's no x, there's no n here. So whatever doesn't have an n, I could pull out of the limit, which I did. Okay, because this does not move to infinity, it's just x, there's no n. And I'm going to put it inside the ln. That's what I did. It's ln of the limit of this thing inside the ln. Is that okay?
Yep.
That's it. And now this limit, I told you at the beginning of today's class that this is the definition of E. So we have 1 over x times ln of E. which is 1. Ln of E is 1. Is this okay? Okay. That's it for today.